All right, we're on to lecture 20, part B. So we're going to keep talking about electron configurations in this part. A few more details I want to tell you about. All right, so before we get into that, let me just remind you what we were doing last time. We learned to figure out the location of electrons in an atom. And the way we kind of write it out is called an electron configuration. And we use this diagonal rule to figure out what order these subshells are going to fill up. All right, now, one thing you might be asking yourself, because, if we get to an element that's kind of big, like even nickel, which honestly isn't even that big, I mean, it's element number 28, it does start to take a while to write all this out. So is there a shorthand we can use, another way of recording or writing down the location of electrons? And the answer to that question is yes. All right, so there is another way to write down electron configuration. And it's a shorthand. It's called the Noble gas shorthand. All right, so let me show you this other method. All right, just to remind you before we get into that, one thing that's going to help us is to keep in mind, you kind of know where an electron configuration is going to end based on where it is on the periodic table. Strontium is going to end in 5s2. Cobalt is going to end in, oh, one behind, right? It's going to end in 3d7. All right, so being familiar with that is going to help us as we look at this other way of writing electron configurations. All right, so let's get to a couple examples. All right, so before we get started, I'm going to take this periodic table and let me just remind you because it's going to help us. Let's write down our row numbers. All right, I'll write down our row numbers. Okay, and then I won't write all these in, but remember this is the S's, S1 and S2. This is the D's, D1 through D10 as we go over, and then this is the P's right here, the P section, P1 through P6. All right, so let's say I wanted you to write out the electron configuration, and I don't know, maybe I'm having a bad day, and I say, write out the electron configuration for me for barium, element 56. Oh my God, are you kidding me? I'm going to have to write in 1s2, 2s2, 2p6, 3s2, 3p6. It's going to go on forever, isn't it? 56 electrons. So how can we shorthand that? All right, well, the way you can shorthand that is something called the Noble gas shorthand. So what does that look like? What you do is you will put the previous noble gas in a bracket, the previous noble gas in a bracket, and then after that, you're going to write plus the rest of the electrons. Plus the rest of the electrons. All right, what does that mean? All right, well, let's start with the word previous noble gas. So the previous noble gas, a noble gas, is something in column 8A. These guys right here. All right, those are your noble gases. Now, so we're going to write a noble gas in the bracket, the previous noble gas, and then we're basically going to write any electrons that come after that. All right, so for example, for barium, you can't go forward, you got to go backwards. I'm going to find the previous noble gas. So 56, 55, oh, the previous noble gas is xenon, which is element 54. So instead of writing out the first 54 electrons, 1s2, 2s2, 3s2, 3p6, I'm just going to say barium is xenon, and then I'm going to go and add on any more electrons that barium has. So from xenon, from 54, I've got to get back through this area. So when I get back through that area, this would be adding, now what level are we in there? We're in the sixth row, so 6. And then it would be, well, it's going to actually end in what? These guys were S2, weren't they? Second column over. S1, yeah, S2. So it's going to be xenon followed by 6s2. So instead of writing 1s2, 2s2, all that mess, you just write it, hey, it's xenon. And then the term after xenon would be 6s2. All right, let's do another one. All right, let's say I wanted you to do, we're going to do a few more here. How about potassium? Potassium is, and actually let me switch colors. Potassium is number 19. Well, it wouldn't take that much effort to do it like the long way, but how can we do it the short way? You find the previous noble gas. So the previous noble gas, you go back 19, you got to go back 18. Oh, it's right here. 18, which is argon. So it's going to be argon followed by, so instead of writing 1s2, 2s2, 2p6, all that stuff, I just say it's argon and then anything that follows it. So what are we going through in that area? So from argon, we got to get back to 19. So that would be, well, it's in the fourth row and it's in the S1 column for S1, like that. All right, we're gonna do another one. All right, we'll do another one. Maybe this is making sense. Might take a little time to sink in. All right, so our next one, let's do phosphorus. Element 15. All right, tell me the electron configuration. Find the previous noble gas. So you can't go forward from 15. You can't go 16, 17. You got to go back. So it's not 14. It's not element 13. It's not element 12. It's not element 11. The previous noble gas is element 10, which is neon. And then we got to write any terms that would come after that. So neon is like the 1s2, 2s2 business, or whatever. And then to get back, we've got to go through this area. So we start here, and then we're going to go through the third row, and we're going to go through the S part of it, 3s2. And actually, now that we're there, we're going to have to keep on going, element 13, 14, 15, over to here. So in that area, we're filling up the P region. To be exact, the 3P region, 3P, and then this is P2. It'd be P3 when it, 3P6, 3P3. All right, so you tell me it's neon, and then you tell me anything you would have written after neon, which is filling up the 3s level and then also some of the 3p level. All right, I'm going to do one more, and then I'm going to give you a couple to try here. Okay, so let me do one more. Let's do one more. And man, my periodic table is getting a mess. Let's erase some of this mess. All right, oh, I might want to write that back. All right, we'll clean it up just a little bit. And just to remind you, this is D land, D1, and if you count over all the way to D10 would be the last row. All right, how about if I wanted you to do, oh, let's pick an element we don't talk much about. How about vanadium, V, element 23. All right, you got to go back from vanadium. The previous noble gas, back. Oh, it's not element 20 or 19, it's element number 18, argon. And then what do you do to get back from argon? So argon is here, and then I'm going to go through this area, and I'm going to keep on going until I get to vanadium. So the next thing we fill up after argon, the area that fills up next, this is the 4s level. And then we're going to fill that level all the way up, and then we're going to go into the D level. Now remember, the D's are one behind, so you're not going to be filling up 4D. You're going to be filling up 3D, and I think if we count over, it's 3D3. Okay. All right. Let's see if this makes sense. I hope it is. All right. So I'm going to put up a one or two for you to try. All right. Tell me about, let's do Se. Selenium. I'm going to erase what I did here. Selenium. So again, you got to think through it step by step. First question I have for you. How many electrons are in selenium? 34. Next question. What's the previous noble gas to selenium? The previous noble gas is argon. Next question I have for you. What are you going to do? What are you going to have to write after argon? So it's argon followed by, should be 4s2. And then we get into the D region, and we fill the D region all the way up. Now, not the 4D, the 3D, 10. And then what am I doing? I'm trying to get to, I erased it, selenium. So then we start going, and now this is the P region. 4P or 3P? 4P. 4P. And it should be 4P, yeah, 4, I suppose. It should look like that. Okay, so yes, at the fourth row over, yeah, this is P4. I'm sorry, I got a little messy. If you have a full-size periodic table, it'd be easy to write in. It's the fourth one over. P1, P2, P3, yeah, P4. All right, with that, one last one. All right, I'm going to ask you a few questions about this one too. Let me erase some of the mesoperiodic table. All right, how about if I ask you about, let's do, I don't know. Oh man, what should we do here? I guess we'll do, let's do silicon. Why not? Silicon, element number 14. What's the previous noble gas? The previous noble gas, back from 14, it is number 10 on the periodic table, neon. And then after neon, what would we write? We would write neon followed by 3. Now we got to get through the third row. 3s2 followed by 3p2. So this is the 3s region, and then you got to fill up part of the 3p region, 3s2. All right, so hopefully that makes sense. We'll probably do an example or two during our Zoom time. So once you get the hang of it, it's not too bad, but it might take a little while for it to make sense. All right, so there's one more term I want to mention in this video, and then that'll be it for this part. Let me flip over. I got to show you one more idea on this one, though. Oh, actually, before we get to the last topic, there's one more example I wanted you to try. Try this one. You're supposed to tell me what's the shorthand electron configuration for Te, technetium. It's element 52 on the periodic table. So you'll need a periodic table handy. Find element 52. And I have to tell you, I'm not going to be able to type these choices in because like this ain't going to show up right on the little pop-up question. So maybe jot them down real quick or look at it. Pause this video. And in a minute, you'll get your choices. A, B, C, D, or E. Okay, I put back up some of the electron configurations we did earlier, and the reason is because I want to point out one more term for you. And this term is going to be important, especially in the next chapter when we talk about how atoms get together to form compounds, all right? So, and that term is valence electrons, valence electrons. So what are valence electrons? Valence electrons are the number of electrons in an atom's outermost shell. The number of electrons in an atom's outermost shell. Now, why do we care about these? Because these are the ones that are used to bond to other atoms. Now, and that's in fact, when we move on to our next section, that's exactly what we're going to be talking about. So with these electron configurations in front of us, we can figure that out. I'm just asking you, how many are in the outermost shell? So just to remind you, when I say shell, that's the big number. So for example, lithium, the outermost shell is the second shell. In the second shell, there is one electron. So it has one valence electron. Now, for sodium, the outermost shell is remember the big number, the third shell. In the third shell, there's one valence electron. Now, be careful. We're going to do a couple more, like oxygen. Oxygen, the outermost shell, the highest numbered shell you see for oxygen, it's actually the second shell. But the second shell has two parts to it, an S part and a P part. And there's electrons in both parts. So if I ask you how many valence electrons there are, you would have to add them together. In the second shell, there is a grand total of 6. 2 in the S part, 4 in the P. That makes 6. All right, It can even get more complicated, honestly. Nickel. Let's go down to nickel for a minute. What's the outermost shell? What's the highest shell you see for nickel? The highest shell I see is shell number 4. Now, so you notice it's not necessarily the last thing you write. And in that 4th shell, there's 2 electrons. So that is in the S part. They're both in the S part. So be careful, because the outermost shell is not necessarily the last shell. It's the biggest numbered shell, shell 4. And sometimes the outermost shell might have more than one region. You have to add them together. Like if we were to do sulfur, again, you would have to add them together. There'd be 6. All right, so with that, we're gonna, I'm gonna go to the periodic table for a minute. I'm gonna show you one last thing about this. One last thing I want to do, and that is tell you, like in the next set of videos, we're going to talk about how atoms get together to make compounds. And I'm going to ask you all the time, how many valence electrons does this atom have? Now, if I ask you how many valence electrons does, I don't know, carbon have, you're not going to want to sit there and necessarily write out 1s2, 2s2, all that business. So there's an easier way to figure out the number of valence electrons. And what I'm about to tell you only works for the columns that have an A. 4A, 5A, 6A, 7A, 8A, 1A, 2A. For the A columns only, the number you see, the Roman numeral, is the number of valence electrons. The number of valence electrons is the same as the column number. Now, before you even think about it, for the B guys, well, we're not going to talk about the B guys much in the next chapter, so I won't worry about them. So what I'm telling you is going to help you out a lot, because we're only going to worry about the A columns. The number of valence electrons equals the column number. All right, so as far as that goes, if you look, we have, if I asked you about oxygen, column 6A, he's got 6 valence electrons. Or beryllium, he's got 2 valence electrons. All right, with that, that's it. That's all I'm going to talk about. I should tell you, there's going to be one more topic we're going to cover. I'm not going to do it in the pre-recorded videos. I'm going to talk about it in our Zoom time. So hopefully you can make it to the Zoom time. If you can, at least watch the recording of it, because I'm going to explain it in there. So there's one topic I'm not talking about in this video, but you'll hear it in the Zoom sessions. All right, there's still one more part to this one, and then you'll be done with lecture 20. All right.